This is Debashish Mishra. So today we will discuss frequently asked interview questions based on DC motor. This is part 2. I have also prepared part 1 question which will definitely help you. First go through this part 1, then go to the part 2, and I have prepared different types of MCQ based questions like Thevenin's theorem, Norton's theorem, superposition theorem, KCL, KVL, important questions on basic electrical engineering. You can go through my playlist, basic electrical engineering step by step, DC machine. These are my playlist. You can check. You will find different types of questions which will definitely help you in interview, in viva bus, wherever you will go, you will find such type of questions. So without any delay, we will start. First question: what is the requirement of starter for starting a DC motor? Which is very important. The options are: it limits the speed of the motor, it limits the starting current of a safe value, it starts the motor, none of these above. So you can see here, I am just explaining the things. We know the formula V is equals to EB plus IA RA. EB is the back EMF. We know IA is the armature current. It is the armature resistance. And whenever, what is the requirement of starter for starting a DC motor? At starting, there will be no EB, no back EMF. So V will be V equals to IA RA, because at starting there will be no EB. So IA is equals to V by RA. We know normally armature resistance is very less, so armature current is very high. Okay, so the purpose of starter is it limits the starting current to a safe value. Okay, so purpose of starter is it limits the starting current of to a safe value, because IA is very high at starting. Okay, so we have seen in our experiment, there is a starter is there, and step by step we have given the supply step by step, if you have seen in your laboratory. Okay, going to the next question. Question number 2. What will happen if a DC shunt motor is connected across the AC supply? See the options: run at normal speed, not run, run at lower speed, burn due to heat produced in the field winding by eddy currents. Option D is the correct answer: burn due to heat production in the field winding by eddy currents. What will happen? A DC shunt motor is connected across the AC supply. Remember this. Going to the next question. Question number 3. To get the speed of DC motor below the normal speed without wastage of electrical energy, what is used? Rheostatic control, wide leanward control, any of these above, none of these above. So you have to remember, it is wide leanward control. To get the speed of a DC motor below the normal speed without wastage of electrical energy, wide leanward control method is used. Going to the next question. Question number 4. These days DC motors are widely used in pumping sets, air compressors, electric traction, machine shops. So option C is the correct answer: electric traction. Going to the question number 5, very important. The speed of a DC shunt motor more than its full load speed can be obtained by. Question, just listen. The speed of a DC shunt motor, speed means N, shunt motor more than its full load speed can be obtained by. Options are: decreasing the field current, increasing the field current, decreasing the armature current, increasing the armature current. So we will see first. Okay, we know N is directly proportional to the EB by phi. Okay, and N is directly proportional to EB by EB1 into phi 1 by phi 2. So, phi is directly proportional to the I shunt, or you can say field current IF. So, N is inversely proportional to the field current. So, N is inversely proportional to the field current IF. Clear? That means if I will increase the field current, speed will decrease. If I will decrease the field current, then speed will increase, inversely proportional. The speed of DC shunt motor more than its full load speed. The speed of DC shunt motor more than means increase. So, IF should be decreased. So, decreasing the field current. Clear, students? So, we can see the option. Answer A is the correct answer, decreasing the field current. Clear, students? Going to the next question. In a DC shunt motor, speed is independent of armature current, directly proportional to the armature current, proportional to the square of the armature current, none of these above. So, you can see here I have told you previously, you can see in a DC shunt motor, speed is N is directly proportional to the EB by phi. So, the relation between N and EB and flux, there is no relation between N and armature current. So, it will be independent. Clear, student? It will be independent. So, answer A is the correct answer, independent of armature current. Option A, in a DC shunt motor, speed is independent of armature current. Clear, students? Going to the next question. A direct online starter is used for starting motors. A direct online starter is used for starting motors. Options are up to 5 SP, up to 10 SP, up to 15 SP, up to 20 SP. So, option A is the correct answer, up to 5 SP. Remember, this is very important. If the speed of a DC shunt motor is increased, the back EMF of the motor will be, options are increase, decrease, remain same, 0. Answer A is the correct answer, increase. What is the question? Same. If the speed of a DC shunt motor increase, N and EB, the back EMF, N is directly proportional to EB. Sorry. N is directly proportional to the EB. Then, if the speed of the DC shunt motor is increased, N is increased means EB will increase. So, A is the correct answer. Clear? Going to the next question. What will happen if the back EMF of DC motor vanishes suddenly? Very important question. I will explain. Do not worry. The motor will stop. The motor will continue to run. The motor will run noisy. The armature may burn. Answer D is the correct answer. I will explain. Wait. Okay. What is the question? What will happen if the back EMF of a DC motor vanishes? We know V is equals to EB plus I A R A R A. So, what will happen if the back EMF vanishes? No back EMF. So, what will V is equals to I A R A. So, I A is equals to V by R A. We know armature resistance is very less. So, higher current, maximum armature current. So, the armature may burn. So, answer is armature may burn. Clear, students? Going to the next question. In case of DC shunt motor, the speed is dependent on back EMF only because back EMF is equal to the armature drop, flux is proportional to the armature current, armature drop is negligible, flux is practically constant in DC shunt motor. Remember always, in case of DC shunt motor, flux is constant. So, in case of DC shunt motor, the speed is dependent on back EMF only because flux is practically constant in DC shunt motor. Okay, these are the questions. So, thank you my dear students. Please like, share and subscribe.